Welcome to SQL Friday number 5 with Markus Ehrenmüller-Jensen. I don't know if I pronounced that correctly, but I think it's close. Markus is going to talk about an introduction to numeric calculations in DAX, and I'm super excited because I'm a complete noob when it comes to DAX. I know some people pronounced it dead when Power BI was released, but apparently it's still alive.
Yeah, very much.
This session is being recorded. It's going to come online. I'll upload it to YouTube and then embed it on sqlfriday.net. So just keep your eyes open in the coming days. It will come up there. Usually I'm able to do it the same day, but now I'm in the cabin. I don't have a good screen, so it might take another day. And I need to do some swimming because it's summer in Sweden. Anyway, I'm really happy to have you. I'm really happy to have you here, Markus, and I'm going to hand over to you. Just the stage is yours.
Yeah, thank you very much. Welcome to my talk, Numeric Calculations with DAX, and that you're joining this talk during lunchtime on the only summer day in Sweden. No, just kidding. Of the Southlanders. Yeah, my name is Markus Ehrenmüller-Jensen, and I have to share my screen, I guess. Otherwise, you cannot see what I've prepared here. So, and moving this window again. Very good. You can see my screen?
I do.
Yes, very good. Then let's proceed. Welcome to my talk. DAX, what is DAX? DAX is data analysis expressions. I sometimes wrote also data analytic expressions, but the official term is data analysis expressions. And I was curious why I thought it was also named analytic expressions, and then I found out from there's a blog post from Jeffrey Wang. So Jeffrey Wang is one, or not to say the author of DAX, of the language, and he wrote this once in a blog post, so that's why I was confused, and I linked both of them in the slide deck. I will provide Magnus with the slides and the demo file right after the thing, so you can start immediately also looking on the examples and the slides if you want.
Perfect.
So DAX was born with Excel because there was, I don't know if you remember that, but there was a Power Pivot for Excel add-in in 2010 and 2013, and this was the first start before we even had a tabular analysis services tabular model, and before we had Power BI desktop. This was an add-in to Excel, and that explains some of the syntax in DAX. So it's used for people, or it was written for people using Excel, so it's tremendously influenced by Excel. As we've seen here on the slides, there's over 100 functions, are not only the same name, they share the same code. So they didn't replicate the code, it's the same code they have in Excel, runs then in DAX. And of course, this is not Excel, this is not spreadsheets. If you're thinking about the tabular model or Power BI, this is like a tabular database, which has something in common with relational databases. So this is also influenced by SQL, and this is also a business semantic model. So it's also influenced by MDX, the multidimensional expressions. So the language you're using, if you're using SQL Server Analysis Services, multidimensional, which was only named Analysis Services until 2012, because until 2012 there was only one version of only one taste of analysis services, which is now renamed to multidimensional. Now we have also the tabular model available. The language is used for many things, at least for measures and calculated columns, and that's what we are taking a look in this. So I'm concentrating here on numeric things. So we're not talking about related or text conversions things. We only will concentrate on numeric calculations here. And you will see in the first examples, the syntax is easy. So if you see a DAX statement, you most likely will get an idea what it's doing, because it's coming from the Excel logic, and there's many of the function names are identical to Excel. And if you know English, then you will understand what the calculation roughly does. The problem is that there's some complexity in the semantics. So there's a function called calculate. And when I first heard of that, I mean, I know what English calculate does. It calculates something. So I assume this is easy. I mean, what does this, what harm or what complexity can be behind? But there is a lot of complexity. So please, if you start with DAX, do not replicate my fault in thinking I understand English, I understand what the function is, but always ignore the name and look up what the function really does. And learning the language makes it, of course, complicated because there's so much complicated and complex semantic behind it. But this is not to make your life harder. It's meant to make your life easier because of the complex semantic. It's easy then to solve complex things in your business with a rather simple DAX statement. So this is a good thing, the complexity. I picked 3 calculations which I'm very much used to in many of my projects, but I learned that not everybody knows how to calculate a sales amount, for example. So I put up a slide here to just talk about what sales amount is. If you have the price and if you know the quantity, then you can calculate the sales amount as price times quantity. That's the formula here. Then we'll have another calculation, the margin. The margin is kind of the profit which we have after we deduct the costs from the sales. So we have the sales amount minus the costs. This is the margin. And then we could also calculate the margin in percentage, and in percentage means in percentage of the sales amount. So we take the margin and divide it by the sales amount. So sorry for having like the sigma symbol here. Hopefully nobody of you had bad times in mathematics in school, but this is the formula. And if you're not sure about how this is calculated, please make a screenshot right now and keep this on the second screen. So because we will not talk about how we calculate this in financial terms, but we will talk about how we will calculate this in DAX, in calculated columns and in measures. So it's a good idea to have this present either in your mind or on the screen. So make a hard copy of that, screenshot of that. The calculated columns is the first thing I start with because it's very similar to what we have in Excel. So you have the calculated column and then you see immediately the result. So learning DAX is a good idea with calculated columns. So that's the reason why I start with calculated columns. Usually if we're referring a calculated column, we always write a table name and the column name. The column name is in square brackets. The table name not always have to be in single quotes, but I would recommend. So if, for example, you have a table called sales, it's not necessary to put it in single quotes. If you have a table like date is a reserved keyword, then you have to put it in single quotes. Or if you have like a special characters or blanks in your table names, which you should have in my opinion, because the names in Power BI, the table names, the column names, that should be the business terms. So no camel case, no Pascal case, but really with blanks and all the things like the business would write that. That makes it easier then for your business users to use the thing because they just recognize what it is. And also you don't, if you build the reports, it's easier because you don't have to change the names afterwards because you just let it like the column or the table is named. And I would recommend always to put the single quotes because then it's the same concept then. So I always put the single quotes, even if synthetically it's not necessary all the time. Yeah, the thing is, this element is called calculate column, but it's calculated row by row, which sounds a little bit perverty. When you hear about it, it's a calculated column and it's calculated row by row. But the thing is that the formula is for one column, so it's only once there. The formula is only once there for the column, and then of course for the whole table, it's then calculated for all of the columns. That's very much like in Excel. You have an Excel table, then you put a formula, and then you have to replicate the formula. We don't have to replicate the formula in Power BI, but then it's calculated for each of the rows where the formula can be applied. A calculated column is also persisted in the model. So if you add calculated columns, not only the formula is added, but also the space or the calculation is done and it's persisted. So the more calculated columns you have, the bigger your Power BI file, the bigger your analysis services tabular model will be on disk and in memory. This is also very important if you're coming from a SQL Server side. If you have a calculated column in SQL Server, the calculated column is not persisted. It's the same term, but it's a different concept. Calculated columns in SQL are not persisted, but in Power BI, in DAX they are. The data type is then determined by the formula, and you can change it afterwards. So no important thing here, and we will concentrate on the numeric stuff, numeric calculated columns. Be aware if you, for example, create calculated columns in tabular model and then you connect with Excel to the tabular model, or you could also open up a Power BI file and then connect via Excel to the Power BI file, to the data model in Power BI. This is possible. Then you're not allowed to put the calculated columns into the values. You can filter on them, you can put them in columns and rows, but you cannot add it in the value region, in the cell region of a pivot table. This is not allowed. Power BI allows this, but Power BI does a little bit of magic behind the scenes. So behind the scenes, it's creating a measure. So even if you only created a calculated column, Power BI will create an implicit measure for you, so you don't see the measure. You didn't ask for it; it's just there, which is a good thing because it makes your life more convenient, because you then can put a calculated column into the values region of a matrix or of a table. This is working. But it makes my heart more hard because my life more hard because I now have to explain that there's something you can't see, but it is still there. So the measure is invisible. And the aggregation which is applied for this measure is done by the default summarization, which is on the next screen. So default summarization, if you have your field list in Power BI, you can then change the default summarization. Normally for numeric columns, for numeric calculated columns, it's automatically set to sum. So it's then added up. You can change this to average, minimum, maximum, count, and count distinct. And per visual, you can also change it. So even in the model, if it's set to sum, you can say in your visual, you can define that you want to see the average in the visual. This is possible by changing it per visual. And then we also have the sum, the average, the minimum, the maximum. Funny enough, we have 3 more: standard deviation, variance, and median, which is not available in the model, but available in the visuals. I don't know why this is the case. And funny enough, count distinct and count, the order of those is different if you pick it up in the model or in this visual. And then Power BI creates an implicit measure for you. As I already said, you can't see it, and it's then, if you pick the sum, of course, it's then doing the sum over the expression of the calculated column or the average or whatever. So let's see the first example. We're writing now DAX, and this is the first DAX statement. So I have the sales amount, and as we can remember from one of the first slides, price times quantity equals the sales amount, and this is the formula we have in DAX. So I'm referring to the sales table, the price column, and multiply it with the quantity column of the sales of the same table, of the sales table, and assign this to a new column, and the new column has the name sales blank amount. And that's what's happening here. So I have a very simple example here, only 4 lines, 4 sales lines for 4 different dates, 1st, 2nd, and 3rd of July last year. Price times quantity times 10 times 3 is 30, 20 times 1 is 20, 30 times 4 is 120, 100 times 5 is 500, and then we have the total of the 670. Here this implicit measure comes into play, so it's summing up. There's an implicit measure which sums up those values. 30 plus 20 plus 120 plus 500 is 670. I calculated this, so this should be right. And we can see this in our PowerPoint. We can see this in Power BI. And the same example here, I changed this somehow to October here, so don't be confused. It's the same thing, 1st, 2nd, and 3rd. And we see the individual numbers, and then we see this is working like that. And I replicated the formula up there, so it's easier for you to see. Of course, putting a formula like that into a text field does not change anything in your model. But in the sales table, we can see there is this sales amount column, should be the first one, and I see the formula up there. To free me of always clicking there, I just replicated everything here, so it's easier for you to follow. Easy as that, I would say. The margin, how is the margin calculated? We take the sales amount, subtract the costs from it, and that's the formula for that. So minus, before we had the multiplier sign, now we have the minus sign. So again, 50 times 50 minus 40 is 10, 120 minus 75 is 45, 500 minus 350 is 150, and then we see the 205 there, But remember, we have a calculated column. It's not calculated this way. There's an implicit measure, which is now already, again, summing up the results of those individual calculations. This is very important to remember. It's not done this way, it's done this way. Currently, it doesn't make any difference, but we will see in the next example, it makes a big difference. So the margin percent. The margin percent is a division. I take the margin and divide it by the sales amount, multiply it by 100, or in Power BI, I can assign in the properties of the field, it's a percentage, so I don't have to multiply it by 100 automatically, will then be multiplied by 100, and the percent sign is put at the very end then, as you can see here. So we have the margin of 5 for the first day, we have a 20 for the sales amount, and 5 divided by 20 is 1/4, so that's 25%. I think this, we can recalculate this in our mind. 5 divided by 30 is 16. 45 divided by 120 is 37%, and 150 divided by 500 is 30%. So we have a margin between 16 and 37%. The margin in percent means if I sales amount by 100, what is the percentage I can keep? So I'm subtracting the cost. That's what our profit lives off. That's what we live off. So in this case, my sales amount was 20. I only had 5% of costs. Now margin is 5%, so the difference between sales amount and so that's the profit more or less. So we have 1/4 of the 20 is our own. With that said, we should really wonder why we have a margin of 109 here. That would mean we are selling goods for 100 euros or Swedish crowns, and what we can keep is 109 of that. This is just not possible. We cannot keep more than we earn from our customers. This is not possible. So obviously there's a problem in here. And we would also expect, like on average, that something between 16 and 37 would be a right number, but it cannot be outside of the smallest and the biggest one. That would be really, really weird to see. Why is this happening? Because we have a calculated column, and as you remember, for the calculated column, we have a implicit measure defined. Implicitly, we didn't define it. Power BI did this for us, and the implicit measure currently shows a sum. So it's summing up the 25 plus the 16 plus the 37 plus the 30, and that's 109. And this, of course, is rubbish. This is not doable. We cannot publish a report like this because this number is wrong. And we can also see this in Power BI. So going there to the margin in percentage, we see this 109 is here. Sometimes I have people and say, yeah, of course, this is because there's a sum assigned here. So for the margin in percent, we have the sum there. Just change this to an average, then we should end up with a better number. Yes, we're ending up with a better number, but still the number is wrong. And we have to change it here, the visual. So my fault. If I change it in the model and already there in the visual, then it's not changing here. So we put an average here. And the average is now showing, that did not work. Oh, wrong column. I wanted to change this one. So average of margin, and change this pick. So the average would be 27, which is close, but not right. So I would not publish a report like that. Don't do that, because people will recalculate the numbers not this way, but they will recalculate it this way. So if I calculate 205 divided by 67, people see this is a different number. So why is this not working? Because I'm in demo mode. So we see 205 divided by 670 is 31, 30.6, whatever, but it's not 27. 27 is the wrong number. Don't do that. So we have a problem in here. We cannot influence this because we only have the calculated column, the formula, and then we can influence how the aggregation is done. But we cannot do this by an aggregation. What we need is that exactly the 205 is divided by 670. And this is not possible in the calculated column. So this leads me why it's important to think about measures. So this is not the right thing. Measures. Now we're going to measures. Usually, if we refer a measure, we can also write the table name and the measure name. But trust me, I'm not sure how. Depends on how much I'm talking if we're coming to the conclusion here. But at the moment, please trust me. Don't use the table names if you're referring to a measure. Only referring the measure in square brackets. Omit the table name there. The measure, that's what I think of a measure. A measure lives outside of the model. It does not live inside of a table. I mean, we have to assign the measure to a table so we can find it in Power BI. That's the only reason. So we have to find the measure in this logic, and there's like a table, and then we find the measures. Or in my case, I came up with a separate measure table, a fictive empty table where I put all the measures. But from a user interface perspective, we have to assign the measure to a table. From a calculation perspective, the measure is not assigned to a table. It's living outside of the model, and let's take a look on the whole model from the outside. And that means that we have one formula for the measure, but the result is influenced by what the model looks like currently. So there could be different filters. There's a context for the measure. There could be filters on slices, on cross filters. There could be a page filter, rows and columns of a pivot table. So in one column, I only see the values for January, and in one row, I only see for the red or the blue products. That's the context. There's constantly a filter applied, and measures are therefore not calculated row by row, because it does not make sense to pre-calculate them somehow, because in your report, you will always have different contexts, and one measure in one report will be maybe the same measure will live in different contexts on the same report. As I said in the table, like we have different columns, January, February, we have different rows, and then we have 4 different values for the same measure. So calculation by default is not done row by row. We can ask for that, and we will that in a later demo, but by default it's not done. And it's therefore not saved in the model. It doesn't make sense to pre-calculate all possible values. That's like what the multidimensional analysis services does. It pre-aggregates things, trying to find out what is really helpful and useful, and then uses disk space for having pre-calculated values. Measures is not done this way. So the measure is calculated as at the moment I need it. So if we add measures to our model, the file will not get bigger because there's nothing persisted except for the simple script containing a single string containing the formula. And the measures behave the same in Excel and Power BI. So there's no difference. I can put them into the values region in Power BI and in Excel because it's a measure. We can use it like that. So for the margin, if you remember, the margin was the margin percentage, which we just failed producing as a calculated column. We can have this as a measure, and it's the margin divided by the sales amount. As you can see here, we have not only to refer the table and the column name, we also have to apply an aggregation function here, the sum of margin divided by the sum of sales amount. The reason is because the measure lives outside of the model. So it looks at the sales table, and the sales table potentially has more than one row containing a margin. So what should we do with those margins? Should we sum it up? Should we take the average? Should we take the smallest, the biggest, or whatever? So you have different ways of aggregating stuff. So this is necessary in the measure. This was not necessary in the calculated column, because in the calculated column we have this row context. We calculate for a certain row, and for this certain row we have only one margin, only sales amount. For the measure, it's completely different. The measure is calculated now, again for the same values. So 10 divided by 50 is 20. 45 divided by 120 is 37, 150 divided by 500 is 30, and now in the total we see 36. That's the number we just calculated in the calculator, 30.5 something, 59 or something like that. So this is the right number because there's no implicit measure. We have a measure, and this measure will also be applied on the total. So now the 205 divided by the 670 equals the 30.6%, and now we're good to go. So this is the right number, what we see. And of course, we can take a look into Power BI and seeing the margin here. So the margin in blue here, that's the measure, and we see the same numbers here. So I'm not cheating in PowerPoint. The same also is visible in Power BI. For the margin was the sales amount minus the total cost. Again, we have to put the sum of the sales amount minus the sum of the total cost, and it's calculated the same way, 50 minus 40, and so on and so forth. And for the total, it's also not calculated vertically, but it's calculated horizontally. So all the measures always calculated horizontally, and this leads sometimes also to confusions because people tend to see the total for the margin like recalculated like that way, and sometimes people are confused because it's not the result is not the result of summing these things up, but the result is calculated differently. For example, I do a project for an insurance company, and for example, they would have claims, and one would be a claim because somebody has cancer, another claim would be because they have back problems. And of course, there could be a claim of one single person having cancer and back problems at the same moment. So if we line this up in a table, then we see that there's like two people having back problems and one person having cancer, but at the end it's only two people. It's not 2 + 1, it's only two people having claims here on this day, because one had cancer and back problems and the other one had only back problems. So this is also important to keep in mind. A measure is not calculated vertically, but always calculated horizontally and influenced by filters. So what we see here, there's a filter on this 1st of July, and that's why we see 50 and 40 and 10. Here, there's no filter on the date, so that's where we see 670, 465, and this is resulting in 205. The same would be true for the claims, for example. I would say different claims. There's two claims fulfilling this filter, one claim for this filter, but in total, it's only two claims we have in the table. Please keep this in mind, because this can sometimes confuse people. For the sales amount, we remember the sales amount is calculated as the price times the quantity. So we do the same thing here. 30 times 4 is 120, the same is here. The second line, 100 times 5 is 500, and then we have 2080 in the sales amount at the total. Why the heck is this? We only sold 120 twice and then 500. This is never going to end up in 2000 or 2000, because we have a measure, and the measure is told, please take the sum of the price, which is 160, and multiply by the sum of the sales, which is of the quantity, which is 13, and this ends up with 2080. Of course, this is again rubbish. So what we maybe thought we can solve everything with a measure, we had a problem with the calculated column. Now we're facing also problems in the measure, and this is something you have to think about. So the problem we are facing here is that we calculate the sum of the price, and if you think about that, this is a no-go. No-go. You cannot sum up the prices of different things. We're literally comparing pears and apples. I don't know what's the English term for that. Or if you have this in German, we have like this term that you should never compare pears and apples, because this ends up in something rubbish. And that's what we're seeing here. So summing up the price doesn't make any sense, and then we are summing up the quantity and multiply by the sum of the prices, which is a nonsense number. That's what we're seeing here. So again, we're facing a problem. This is not doable this way. We cannot sum up the price. So how can we calculate this correctly? What we indeed need is the following. We have to calculate the price times quantity for the whole sales table. So these lines, 10 times 3, 20 times 1, 30 times 4, 100 times 5. But as soon as we finished with all the rows of this table, we are not allowed to replicate the same formula for the total, but we now have to aggregate the results. And this is what the sum x does. Sum x means take the sales table. So sum x has exactly two parameters. One table, the sales table, this is this thing here, and then a formula, an expression. And this expression is done for every single row of this table. And after it's finished, it's like a loop. Yeah? If you're a developer, we're looping over all the rows, a cursor. Yeah? God forbid, do not define cursors in SQL Server, but that's what we're doing here. We have a loop with an iteration here. That's an iterator function. So we're looping over the sales table, calculating this expression for every single line, and then at the end we're summing up the numbers, and that's we end up with 670 here, the right numbers. Sorry for that. So the sum x, so x like iterator. I don't know why they named it x. It could be anything, as I told you. Forget everything about the English, but all the functions ending with x are iterator functions. So there's sum x, there's also max x. This is not a typo, max x with double x, min x, there's average x, there is concatenate x, so you can concatenate strings, and there's some I always forget. Yeah, but that's the functions here. So this allows us now for asking Power BI or DAX in a measure to have the row context, calculate something row by row. Now we're calculating row by row in a measure. Now, by default, the measure does not do that, but we can ask for that with the help of this iterator function. So that's what we got here. So if you remember, sum up the first part of this talk. What I'm doing time-wise? Halfway. Very good. Very good in time. So we can sum up now, and then we take it to the next level. And if you have the time, we put it to the over next level. So sales amount. How can we calculate the sales amount? If I do this live, I have like Mozart's balls, small chocolates with me. I cannot share chocolates here, but maybe you can interact with me, unmute yourself, or use the meeting chat. Is the first or the second or both are the right calculations? There's one question. I believe X refers to expressions. Yes, as in sum on an expression. Yeah, I think this is a good good explanation. I just wanted to make a joke because I don't really like naming. Most of the namings Microsoft is coming up with, and then they're changing the namings back again. Yeah. But I think, yeah, X is the right expression, the right explanation for the X in the sum X. So what do people think? Can we have both, or only the first, or only the second calculation? Which one is the right to calculate the sales amount? So totally, you may unmute you, otherwise, but maybe you're currently eating, you do not want to talk with me.
Or having a beer, or either unmute or just write in the chat.
I cannot hear you, Magnus. You're muted, at least for me, or is it like again it's my
I am not muted for the moment.
So I will quickly change this here. More actions, device settings, and I will change this to the speaker here. So now your speakers are muted.
Do you hear me now?
Now I hear you. Okay.
Awesome.
The same effect like I had with my students.
But this time we heard you all the time, which is good.
Yeah. Which is good. It's always good hearing me. Yeah, it's not that important that I hear you, to be honest. So to sum this up, do we have anyone reacting here? No, nobody.
No one is daring to guess.
First, obviously, so otherwise the numbers will be just wrong. So.
Oh, I didn't get the first one.
Well, you have obviously you will get distortions if you use the second one.
Yes.
Where you sum first. Yes. So
summing up the price is rubbish. Yeah. So we're not allowed to do that. And the first one is possible in measures and in calculated columns, even with the sum calculation. The second one only can happen in measures. So take care of your measures there. For the margin, again, we have here are both possible, or is only one possible?
I'm gonna take a guess and say both are possible. And B.
Yeah.
Do I get the chocolate now?
Yes. Next time we meet in person, you get a chocolate, and also Justin, who also got it right with both. Yes, both are possible, and this is just mathematics. So maybe you can remember back in school. I mean, in German it's Klapustri, Klammer before plus, before minus. So like there's this order of rules when you can apply which, and of course, and you can exchange minus and plus. So that's why both are possible, but you cannot exchange multiplication and the summation, or the division and the summation. So this is both possible. So we have no problems at all with such kind of calculations. Either choose calculated columns or measures, and then with the margin in percent. And can we use both or only one? And if it's one, which one?
I mean, it's the same as before, right? So only the first one would work. Let's see if I. Yeah.
Exactly. We only can divide the results of the summation and then divide it with the total line. So the sum was the total. And if we take the calculation, the division before, and then sum up the results of this division, this is rubbish I would say in all the use cases. I can't remember that I've seen any use case where maybe there's one or two in the world, very special things, but usually you cannot just sum up the results of divisions. This is not what people would expect from a percentage or from a ratio. And the first one is possible in measures and the second one would also be possible in the other one. So again, take care of your calculated columns here. If you divide there, please remember this will potentially lead to the wrong result. So the takeaway of the first thing is, please take care of your numeric calculations. And it doesn't matter if it's ordinary columns or calculated columns. So ordinary columns would be columns you import from your source, because take care of the default summarization. Set it to don't summarize for all of the columns where you don't need any aggregations. And for example, by default, the price or the calendar year, the month number, get a sum symbol, which means, so if we go there to the Power BI, what I'm referring to, if there's this sum symbol here, assume it work, yes. This symbol means there's a default summarization turned on. For this one, there's no default summarization turned on. And for the price and the calendar year, it should be empty. Because otherwise, if you take the calendar year, for example, to a table, it will then aggregate the calendar year and you will see 3 million or whatever. That doesn't make any sense, instead of having a list of calendar years what potentially you would expect. So please, after you loaded stuff into Power BI, check the don't summarize. For all the others where you want to have the aggregations, please create measures for them, explicit measures, so you are in control what kind of aggregation is done, summarization, aggregation, or more complicated calculations. This will then work in Excel and Power BI the very same, and hide the original column. So in the sales table, then hide the original sales amount column if there is one. And if you ask me, you should not create any calculated columns. Try to stay away from calculated columns, as we have like problems with calculated columns which we cannot solve as calculated columns. We have seen there's also potential problems with measures, but we could then solve this in measure with some X, for example. So stay as much as possible with measures. This will also have your memory footprint of your model smaller, because measures are not pre-calculated, they're not persisted in the model. Only use calculated columns if it's really necessary, and there is sometimes the case that you have to filter on something like the result of a calculated column, and you cannot filter on a measure, or some visuals do not allow you to put a measure into one of the fields. They only ask you or allow for calculated columns. Then you have, of course, come up with the calculated column. But otherwise, stay away from calculated columns. That would be my first tip here. So we bring it to the next level. Are there any questions here at this level before we make it a little bit more complicated?
Nothing in the chat that I can see. No.
Yeah. So next level would be is the question: can we use an iterator like the sum x inside of a calculated column? And if we can do so, what's the result after that? So we're not doing educational examples. And can we use a measure inside of a calculated column? And what happens if you use a measure which is not pre-calculated, put in the calculated column, which is then persisted in the model? That's what we'll see in this example. So what I took here is the formula. You should recognize this formula is the same we used in the sales amount calculation of the measure, but now we are having a calculated column. I put this in orange, and we can see here I put the table name in front of that. So this is the hint. We are talking about the calculated column. So what if I use this calculation, sales, sum x, sales price times quantity in the calculated column? If you remember, for having a sales amount in the calculated column, we only had to put the formula in there. It automatically then replicated this for all the lines. But what if we're explicitly asking for this row context? What's happening? And what's happening is we end up with the same number, which is the total of the sum, inside of all the rows. I mean, this is something you could expect or not. I just want to explain what DAX does and what we have to live with. The explanation for that is the following. For the first row, it's calculating 10 times 3 and remembering the calculation. And for this for the first row, it then continues iterating over the whole table. So for the first row, it's also looking up the second row, calculating that and summing it up. And for the first row, it's also iterating over the third row and the fourth row. And this is then done for all of the rows. So we have two loops. One loop because we're inside of a calculated column, which is calculated row by row. And then per row, we're asking again for taking iteration over the sales table. That's why we end up with the total of the sum in all of the rows. That's something probably you won't directly use like that, but you could use it like for calculating ratios, etc. Again, to have a ratio inside of a calculated column, and then maybe bin the result of this calculated column to have like small, medium, and high, and then you can filter on small, medium, and high. That would be an application for that. So the calculated columns raw context is not filtering. That's the important thing, which may be confusing, because people could think, I'm currently at the first row, so the sales table should only look like the first row, but it doesn't. So inside the calculated column, every row can potentially see the whole table. So this is not filtering. The row context is not filtering. So that's why we get the whole sales table for all of the rows here, and we end up with the total of the 670 here. What if we put the sales amount measure, which contains the same formula? You can remember, where's the formula? Put it here. So we have the sales amount measure has this exact same formula. If I put this formula not directly into the column, but I have a measure containing the formula and now referring to the measure. For some reason, no, this is not the measure. This is the calculated column. That's why I'm putting the table in here. So I'm referring from one column to the other column, and this is just replicating the values. That's what we would expect, I guess. Yeah. So we're just copying one value to the other one because we have a row context, and this row context of the first row is only seeing one single element from the sales amount, and it's just copied there. But the more exciting stuff is the second one. So of course we have this row reference. If you put the measure, it's what I just introduced to you. If you put the measure, and here we have the measure, yeah. So the measure is defined with the same calculation we previously have seen with the calculated column. So we're iterating over the sales table. The same thing we just had directly in the formula of the calculated column, and now I'm referring a measure, only the measure name here. So what's happening here? Again, you can have one or the other expectations. Fact is, we're seeing only the sales amount per row and not 670 here. Why is this? This could be confusing because it's the same formula. It's just inside of a measure and then referred to in a calculated column. The reason is because if we're using a measure inside of a calculated column, the row context of the calculated column is implicitly, so we didn't ask for that, it's just happening, a transition to a filter context. So in this case, the first line, because we're referring a measure, the measure only sees the sales table as one single line, the current line. And if it's executed in this, the calculated column is executed in the second line, the sales table for the second line looks only like the one line here. So if you're referring measures inside of calculated columns, the row context is transitioned into a filter context. This is something also we have to think about and have in the back of our mind, which is confusing if you start with DAX. But it's really, really helpful because we can tweak things here. The same is happening with the calculate. So the same example. So I'm again having the sum x, the same formula, which in one case resulted to 670, and in the other case, if you had it inside a measure, led to the individual sales amount per row. What if you take this calculation sum x and just put a simple calculate around that? That's what I mentioned previously. I mean, calculate, but what does that mean in English? It's calculating something. What could be the effect of asking explicitly to calculate an expression? Of course, the expressions are calculated, but calculate is a really, really mighty, powerful function. And this function does several things, and one of the things is that it is transferring the row context to a filter context. So if we using a measure, this is done implicitly, but we can explicitly ask for doing that with the help of the calculate function. So now we have the same formula like in the first example, but put it inside of calculate, and now we end up with the same like if we had used a measure for that. So we get the individual sales numbers, because again, calculate is explicitly transferring the row context to a filter context. Yeah, something maybe you can then try to digest on the afternoon. Yeah? So the takeaway from the second level is that
calculate. I think I'll need to contemplate that over a glass of wine or something.
Yeah, maybe. Yeah, if this helps you, then of course, yeah, aquavit or whatever is your drink of choice, your beverage of choice. So to calculate columns, if I reference other columns, it's done row by row. So this is exactly the same number. And I have a row context, and this row context inside of a calculated column does never filter another table. If I have the calculate function inside of the calculate function, the row context is then transitioned to a filter context. We can explicitly ask that, or we could just hide the calculation in a hide it in a measure and then reference the measure. And if you're doing that, then automatically this calculate is wrapped. Implicitly it's wrapped in calculate, even if you do not see that. And as I said, this is confusing. And that's one of the reasons why you should always be very, very sure if you see a calculation, if you're referring a measure or if you're referring a calculated column. Because if you're referring a measure, then the row context is transitioned to the filter context. If you're referring another column, this is not done unless we're using calculate. So it's very important to mark your columns and measures to see that this is like a column and this is a measure, because there's different things concerning the row context and the filter context happening. That's the reason why I recommend to always use the table name for the columns, even if it's not possible, if it's just necessary. If you refer inside of one table, it's not synthetically, it's not necessary to mention the table, because I'm in the sales table. I can just refer the other column in the sales table without naming the table. But you should it, because it makes it more easier to recognize is this a column or a measure. And the measures, you should always omit the table name. So we know that there's a measure. And for measures, it's not necessary, because as I already said, measures syntactically live outside of a table. So we don't need to state a table for the measure. We can always refer to measures without the table. And this makes two things. One, it makes very clear that there's a context transition happening in the formula. And the second thing is that we can then move the measure. So maybe you start with having the measure in the sales table, and then you find out in Excel, for example, all the measures are always on the top of the field list, and you want to replicate this in Power BI, then you can create a measure table and transfer all the measures into the measure table. If you refer the measure by naming the table name where they sit, then you screw up your model, because your report will not work anymore, because the table doesn't, the measure doesn't sit anymore in the sales table. It's now sitting in the measure table. Yeah, we're doing very good. So we can bring it to the next level. So you earn at least three glasses of wine for this evening to contemplate about the things. So I hope you still bear with me. Yeah. Are there any questions at this point? Because we take it to the next level.
Nothing now. No.
Okay.
It's all confusion.
All confusion, obviously.
I mean, for me, this is all new. I never touched DAX. I just heard it's powerful. So
yeah, it is because of just those reasons, which can be confusing. And yeah, you do a recording of this. You always can then watch the recordings. And as I said, I share the slides and the samples. You can play around with that as well. Even I look up my slides sometimes, because I have to remember, yeah, this is the reason, because this is the concept. Yeah, so it's very important to have this in mind, or have a possibility to look this up again.
True.
One third level, and then I will finish my wrap up and my talk. So what we now try is to explicitly manipulate the filter context. So we have seen, if we put a formula inside of calculate, then the row context is converted to a filter context. But calculate can make more. So I can put in an expression, and then I can add up more parameters to the calculate function. And for that, we can explicitly manipulate the filter context. This is also very, very helpful, as we will find out in a minute. So what I have here is, it's in blue, and we have the calculate symbol up there, so we know this is a measure. So we're talking about measure here. And the measure does the following. It refers another measure, the sales amount. And then I put it in calculate. Doing that inside a measure, referring another measure in calculate, doesn't do anything, because inside the measures always the filter context is applied, and there's no row context. So no row context has to be transitioned. So this would not change anything, but we can add up more parameters, as you can see in the comma after the sales amount. So I add up a filter here. So I ask, please, for the sake of the measure product A, don't show me all the sales amount, but only show me sales amount which fulfill the condition where the product description is A. So what we end up with is I have the products A, B, C, D. I have a total. I have the sales amount 30, 140, 500. The same up to say 670. So the same example we have seen in the previous slides and examples. And with that, the expectation could be either we only see the sales amount where the product is A, or we see the sales amount of product A in all the rows. Both could be theoretically possible. As we see, what we have to live with is that calculate does it this way. It's not overriding the filter context. So what it does is the following. It stands at the first line. So the product description is A. So there's a filter context applied to the calculation. That's why I only see 30. That's why I not see 670. I only see 30 because I only see the sales for product A. That's what we want and would expect, I would guess. Here, it's adding up the filters. So I have one filter on A, I have a second filter on A, so we end up with 30. This is no surprise, I guess. Maybe it's a surprise for you that we see the 30 here. Maybe we would expect that we don't see anything here because we are asking for product B and product A would not have a result here. What's happening is that the calculate statement does the following. It's not only applying this filter. Before it's applying the filter, setting the product description to A, it's removing all existing filters on the product description. So for this line, for this the 30, we see the 30 here because we have an existing filter on product B, but before this filter is applied, this filter is removed, explicitly been removed by calculate. So then we end up with no filter on product A, so we would see 670. And then the filter on product description equals A is applied. That's why we see the 30 here. So this is what's happening in the DAX with this kind of syntax with the calculate. What if you only want to see the there's a second syntax which I want to show you because it's more intuitive to read, because what we just have seen is the short version. So this is like syntax sugar. It's the short version of what's done. What we see here is the long version, and it's doing the same, but it's explicitly showing me what's happening. Because if I ask for sales amount, calculate sales amount and an expression here, indeed it's done, it's doing the following. It's applying two more functions. So one, the all function removes all the filters existing on this column. So it's removing the filter on product description. And then after it's done that, it's applying a filter on A. That's why we end up with a 30 in all the rows. So if we want to have only 30 when the product is A and nothing in all the others, you just have to change this part. And that's what we do in the next expression here. So product A only means that I apply the filter. I apply it on the product table. I want to apply a filter on the product table, but I do not remove anything. I just use the product table as it looks like in the current filter context. And in this table, we have a filter context. So we have 4 different products, and we have a total. So there's no product selected, no product filter. So we have all the products, and then we end up with 30 only the first line, and we also end up into 30 in the total. So that could be a good thing or not again, but that's how you can influence this with the calculate statement by either just give the expression, then an existing filter will be removed before the new expression is applied, or we use the filter, adding up, mentioning the table we want to apply the filter, and then the column. And then we can derive on ourselves if we put the all there, so we're removing the existing filters, or we do not put the all here and no filters removed then. So that's what we get here. So without all, then there are filters combined with an N. So the filter is now A and it has to be A. The filter has to product B and it has to be product A, and this is not working, so it's ending up with no row showing up. And then we can also see the calculation, for example, for the sales of all the sales. So I'm sitting in individual lines of individual products, but I want to see all the sums like we had as a side effect in the calculated column. How can we do that? Yeah, we're putting an expression here and just stating all over the product description. So this removes all existing filters on the product description. That's why I end up with 670. Why would I do that? I mean, this row or this column is very useless, but again, I would use that for calculating ratios. So I want to see how much has the product A in ratio on all of the products, or how much does the product A have in relation to product C. That's how I can do it explicitly by removing filters and adding filters with the help of the calculate function. So this is how we change the filters there. So the row context and the filter context is a really, really important concept to understand to succeed with more complex calculations in DAX. And there's ALLSELECTED. ALLSELECTED is a different form of the all. What is if there's a filter outside of the current visual? So I filter on the product B or I filter on the product A. So with all, I always see the 670. If I use ALLSELECTED instead, this is what this result what we're seeing here. It's then the filter of the product B I used in the slicer outside of the current visual is still kept. So DAX is then building up a history of when a filter is applied or not, and ALLSELECTED is only removing the filter applied within the visual, but not outside of the visual. And this is, in many cases, I see that people would expect the ALLSELECTED, because if I apply filters out there, I only want to see 140 because I selected product B and do not want to see all the others. But this depends on the use cases, and always, yeah, talk to your report users what they would expect. And there's many possibilities to build up almost everything in Power BI. So takeaways is that calculate can add filters, it can remove filters, you can even combine adding and removing filters, and that the filter in calculate, if we have an expression there, automatically overrides an existing filter in the same table. So in what it implicitly does is applying a filter on all of the columns. So it removes all existing filters and then first applies the new filter. And we can also apply all within calculate to remove just all the filters, so we see everything. And ALLSELECTED is a little bit more picky because it reserves the existing filters outside of the current visual. So wrap up. Now you succeeded. There were 3 levels of DAX. So DAX has an easy syntax. I think reading the formulas I just did show you is rather easy. You get an idea what the thing is doing. But taking it to the next level, you have also to understand what calculate does, what is a row context, what is a filter context, what is applied at which. I would recommend not creating calculated columns. Stay away from calculated columns as long as you can. Create measures instead. I just introduced DAX with calculated columns because it's more easier to see, because you see the result immediately in the table. And you have to do calculated columns or use Power Query M or calculate them in your data source if you want to filter on them, or if you use certain visuals which do not allow you to use measures. Measures for all of your calculations. So no matter which kind of calculation it should be, use a measure for that and not a calculated column with the correct aggregation, and hide always the original columns. Otherwise, you end up with 2 sales amount elements in your model, like I have with my Power BI file. So this is only for educational purposes. I have a calculated column called sales amount, like down there. Zoom in a little bit. So there's a sales amount here. This is a calculated column, as we can see with this symbol. This is like a table with a sigma. So this is the calculated column. And I also have a calculated a measure up there. Please never do that. This is only for educational purposes. So I refer to the sales amount and the sales amount something. But please do not publish or give away a report like that if it's not for educational purposes, but for production. And include always the table name when you're referring columns, and always omit the table name when referring to measures. With that said, I'm just finishing in time, I guess. Yeah, 1 minute to go. Are there questions?
I don't see questions, so now is the time if you have any. We have a thank you from Luna. And a thank you for me. It was really, thanks for the great presentation from Nicola. Yeah, I really enjoyed it. It's like I said, it's all new to me, so I learned a lot. It's a really good start. So I think I need to keep the recording and your slides and have it as a tutorial to start learning or keep learning. More insights than confusion. Good, Anand. Thank you. So I'm going to take over presentation for a short while and show this. Can you see me presenting now?
Yes.
Hey, good. So I want to thank Markus for presenting on SQL Friday. And as you can see on this slide, we have a pretty good schedule coming up. We have Mike Bird next week, who is he's going to present from Texas, which means it's going to be 5 a.m. for him when he is presenting. So he has to set the alarm clock on middle of the night something. And so I'm thankful for that. Mike is a former rocket scientist and fighter pilot who turned SQL geek. So it's going to be nice. Then we have Ben Weisman the week after that presenting data analysis using GitHub, Azure Data Studio, and big data clusters.
I expected Visual Basic, but now I'm disappointed.
Yeah, I mean, he's a really big Visual Basic fan, and so am I. So we have a lot to talk about. Maybe we should skip the actual presentation and show some Visual Basic 6.0 stuff. But I'm really proud to present this upcoming schedule. As you can see too, we have 2 empty slots, August 21st and August 28th. So if anyone sees this and feels like I think I could contribute to this, please go to sqlfriday.net and fill in the call for speakers form, and we can take it from there. But again, thank you, Markus, for coming to SQL Friday. I was really happy to have you. I'm really happy to learn some DAX, and I'm going to try to keep learning more DAX.
Very good.
Thank you.
Bye-bye.
I will stop the recording. There we go. And